So, I talked about some of the basics, and again, it's not easy though, but it's not the worst thing we've ever done. It's more that you have to make sure you get into practice, and you have to pay attention to some of those little details. I don't have a whole lot of exponent sheets left, but if you need some, I have some, and I will make more copies as soon as I have time to today. So, basically with multiplication, we've done this because when we reduce a radical, we take something like the square root of 27 and we break that into the square root of 9 times the square root of 3. So any radical we can make into a multiplication problem. So if you think about it logically, we can also work backwards. If we have two radicals that we're multiplying together, we can just multiply them. So square root of 9 times square root of 3 is just the square root of 27. We just took 3 times 9, 27. So the other lesson we did, where we did adding and subtracting, you have the same index number and the same radicand, or multiplying and dividing, which we'll do tomorrow. Before multiplying, you have to have the same index, but the radicand can be different. So the inside, the 3, is okay to multiply those together. Now I'm going to go to the whole analogy that I used the other day with the variables like 3x plus 4x. Just because it doesn't work as well with this. I mean, it does make sense, but I think it's more confusing. But the biggest thing is, again, when you're multiplying, as long as you have the same index number, you can multiply those. Always check that you simplify at the end. So if you want to have your answer, make sure you simplify. Some of these you can simplify at the very beginning. I'll talk about that in a second. If you choose to do that, make sure you're still checking to see if you can simplify at the end. So, getting right into it, number 1A and 1B, they're the exact same problem. One of them I'm going to simplify at the very beginning. That is, one of them I'm going to simplify at the end. One of them I'm going to simplify at the very beginning. I would definitely recommend doing it at the beginning. So, if we have the square root of 6 times the square root of 8, if we're going to reduce at the very end, all you need to do is take, since they're both 18, is 108. We multiply it out, that is the square root of 108. And we can reduce that radical just like before. So this is the square root, so 108 would be right around here. 108 divided by 100 isn't going to work. Divided by 81 doesn't work. 36 and 3. So that is the square root of 36 times the square root of 36. So this is 6 root 3. Multiply square root of 6 times square root of 18, you end up with 6. That's the way I would recommend doing it. That's why I wanted to do that one first. Multiply together first. Multiplication or dividing is going to be the same way, where I think it's everything together first, and then you deal with simplifying. Now, the other way you could have done this one is you could simplify first. So what I mean by that is the square root of 6 you can't do much with, but the square root of 18, you can make that into 9 times 2. The square root of 9 is 3. So we have 3 root 2. That's the 18 part. The 6, again, can't do anything with that, so it's the square root of 6 times 3 root 2. The problem with this, and I chose this one on purpose, is because the 3 doesn't get multiplied by anything. Technically, it's a 1, so 3 times 1 is 3. And then multiply inside your radicals, and we'll talk about this later. You end up with 3 root 12. This is the reason I don't like this method. Sometimes it works out really nicely, but other times it works out like this one, where we can still simplify further. So I mean, some of you guys maybe think it's easier to simplify a smaller number, and then when you're done, simplify another small number. So you're simplifying twice, but it's 18 and 12. It's not like a 108 like the last one. I personally think if you're going to reduce, I would rather just wait till the very end so you only have to reduce once. Because this one, again, your square root of 12 is now the square root of 4 times the square root of 3. Square root of 4 is 2, so that's 3 times 2 times square root of 3. 3 times 2 is 6. So that is where you get your 6 root 3. That's the same thing before. But again, for that one, you have to simplify twice. You don't have to do that. However, if I would have given you one you didn't have to do, I think it would have left some of you guys astray, where you would have thought, oh, it's way easier to simplify at the very beginning. And again, in some ways it is. You just have to remember at the very end, you might have to simplify it again. That said, that's the punchline of today's lesson. Multiplying those radicals together. So if you are in the square root, you just multiply whatever's inside the square root. So square root of 5 times 8 is 40. That's just the square root of 40. Again, the double-edged sword with this one is now you have to make sure you're 4 times 10, I think that's one. Square root of 4 times square root of 10. Square root of 4 is 2, so you have to do 10. Example, I'm not going to take the time to do this, but if you would reduce your square root of 8 right away, I think if you reduce your square root of 8 and then multiply it, I think you get that answer. So that one would have been easier if you simplified first. However, like I said, the problem is not all of them are like that. Some of them, if you do that, you're going to have to do it twice. Number 3 is an important one. It's not that hard, but it's an important one I want to make sure we talk about. Square root of 7 times square root of 7. The long 7 times 7 is 49. So that's the square root of 49. Square root of 49 is just 7. By accident, since it's square root of 7 times square root of 7, you can think of it this way. It's the square root of 7 multiplied by itself, so it's squared. Well, you guys all know the squared cancels out the radical. So when we solve it that way, so that's one way to think about it. I'm still very much going to encourage you guys to show your work. That's square root of 49. But if you set the square root of 7 times the square root of 7, I can live with that. But for future stuff we're going to do today, I would encourage you to go ahead and show your work and say the square root of 49. I think that helps a lot of students. Moving on to number 4. This one's a little bit different, and this is one of the reasons why I tell you guys to show your work, is because with number 4, people see this just 7. Well, it's not, because it's not the square root of 7. It's the third root of 7. So the third root of 7 times the third root of 7 is just the third root of 49, and I don't think we can reduce that at all. 49 and 27 doesn't work, and 8 doesn't work, so that's as reduced as I can get. There, because again, I want to make sure you guys see the difference between square root of 7 times square root of 7, reducing really nicely, and the third root of 7, how that doesn't work very nicely. Now, to give you a little bit of a spoiler alert, in the future, we're going to end up having number 10. We're going to have 3 of them. We'll talk about that when we get there. I don't know why I should put that next, or where I should put that, where it fit in. Now to get back on track, the third roots, again, as long as they're the same index number, we can multiply those. So 5 times 8 is the third root of 40. 40 is on our list. 40 would be right here. So 27 doesn't work, but 40 divided by 8 does. So this is the third root of 8 times the third root of 5. The third root of 8 is 2. Now again, some of you guys are going to think that we took one step forward, one step back. Because the third root of 5 times the third root of 8, when we reduced this, we ended up with that same thing. I don't want to risk that. I know the third root of 8 was 2, so if you want to do it that way, just be careful. If you do it like that, I do not recommend it. The other one I want to make sure you see is one that you have a negative, the third root of negative 16. Do not put the I in there. I only works because you can't take the square root of negative. The square root of negative 16, you need an I, you can't take the square root of negative, you can. It makes sense, because let's just do, well, we'll do this way. If you have something squared, you're multiplying by itself. So if you have negative 2, it'd be negative 2 times negative 2, that's going to make it positive. You can't have any negative numbers. Number, you multiply by itself, it turns a positive. But it's to the third power, so we have another negative. Well, then all of a sudden, this is negative 4. Positive 4. Multiplied by negative 2 makes that into a negative. So if it's an odd exponent, you could get negative numbers. Which means if it's an odd index number, you could have some negatives in there. Now I will give you a heads up to make it a little easier for you. I don't think I'm going to give you one that's a fifth root. Those very often. So really, third roots to look out for the negatives. That said, do this the same way as before. Negative 16 times 4 is negative 64. So the third root of negative 64. If you look on our list, 64 is on our list. Works out really nicely. So this one actually reduces down to just 4, but remember, since it's negative 64, it's just negative 4. Don't make that, you don't have to have an I, you don't have to worry about any of that. Just negative 4. And number 7, the last one like this. Again, we have the third root of 7, but it's multiplied by the third root of 7, multiplied by the third root of 7. So technically, it's the third root of 49 times the third root of 7. So instead of distributing, I just multiply these two first. Then 49 times 7 is 343, so it's the third root of 343. But if you look at your chart, that is just 7. Now, I don't know how often we're going to get into this, but if you think about it, the reason I put it up there is it makes sense. Because if it's a square, you need 2 of them to cancel that radical. If it's a third root, then I need 3 of them to cancel that radical. If it was a fourth root, you need 4 of them, so on and so forth. I honestly don't know if we'll get into that at all. I just know I have in the past, and so I figured I'd mention it while it was on the top of my head. Are there any questions so far? So far, I'm hoping it's not too bad. You're just multiplying those numbers together. So now the only difference is multiplying with the coefficient, with that number in front. And I wrote this down a little bit later, I guess. Maybe I should have put it here. But the biggest thing is multiply normal numbers by normal numbers and radicals by radicals. So you will never be able to take this 5. You'll never take the 5 times the root 7. You can only multiply normal numbers by normal numbers, so 5 times 2. You can only multiply radicals by radicals. Square root of 3 times square root of 7. So 5 times 2 is 10. Square root of 3 times square root of 7 is square root of 21. Double check. Can you reduce 1? You cannot, so that's your answer. But again, in the back of your mind, every time you get an answer, you want to double check to see if you can reduce. Number 9, 2 root 5 times 6 root 8. 2 times 6 is 12. 5 times 8 is square root of 40. This one, we can reduce that 40. We just did this one. 40 is the square root of 4 times the square root of 10. The square root of 4 is 2, so 2 root 10. 12 times 2 is 24, so 24 root 10. Now again, don't forget, honestly, I think your calculator, I need to see all your work, because again, I think your calculator does this. If you just type this in, multiplying, I think it gives you that answer. But you can check your work with your calculator, whether it gives you the answer or if you have to use decimals. Calculator can help you check that. Don't make this harder than it is. 4 times 2 is 8. And again, I'm not saying that this is easy by any means. It's just not much harder than the other ones. 4 times 2 is 8. Then we have the square root. 3 times 5 is 15. X squared times x is x to the third. Then we have y squared. Can we reduce that down at all? Not to 15, but the exponents. So when we do this, we do it the same way we did before. And again, I know it's some work, and I think that's the reason why it's difficult. So we have 8, the square root of 15, which we can't reduce that down at all, so that's kind of handy. The square root of x to the third, and the square root of y squared. Again, if it helps to put the 2's for these, you can. The 8 doesn't change. The square root of 15, we can't reduce that down at all. If you want to use your list right here, 9 and 4 both don't work. The square of x to the third. Remember, that's the one where I want a number as close to 3 as I can get without going over. That is a multiple of 2. So that's going to be x squared. So that is the square root of x squared. Remember, if I have 2 x's there, I need 1 extra x to make the 3. Then the square root of x squared is just x, so I have x root x. Again, if you want to put the 8 and the 15, I always like to put those on the same line. Then the square root of y squared, 2 divided by 2 is 1, so that just ends up being y. So the very last part of this, again, same thing as before. Everything that's not inside of the radical, you put together. 8xy. Everything inside the radical is in the same radical, square root of 15x. So again, when I say don't make it harder than it is, it's not easy by any means. But I think it looks a lot harder than it really is. When you look at it, I think there's a lot of steps to it, but each of those steps really isn't too bad. There's a lot of them. We'll go ahead and finish this. I was pondering skipping it because we're going to skip the you-do sections because we don't have a whole heck of a lot of time. We only have about 15 more minutes. Number 11, 3 times negative 2 is 6. Negative 3 times 9 is negative 2. Remember, that's okay because it's the third root. And the third root of 27. Oh, that's on our list, so that's really awesome. The third root of 27 is 3. So that's negative 6 times negative 3, which is positive. That one's a little bit easier. Then number 12, again, it's very similar to the one we just did. What was it, number 10? The only difference is it's a third root. A little bit more practice with these. That's the third root. 50 times is 750. X squared, there is no other x, so it's just x squared. I should have changed this one so it wasn't as long. Then we have y to the third, nothing combines with that. And then z to the fifth and z is going to be z to the sixth. So again, terrible steps to it. So the third root of 750 on our chart, 750 would be about here. So we'll see. I bet the 125 works. So let's just make sure the ones don't first. Again, I think 125 is going to be your answer, but I tried the other ones just to make sure I didn't make a mistake because that'd be a bummer. So this is the third root of 125 times the third root of 6. 125 is, so that ends up being 5 times the third root of 6. Sorry, that's kind of mushed together in there, but I'm trying to save some space. Then the third root of x squared. Can't do anything with that. The 3 is bigger than the exponent of 2. So again, that rule, trying to get as close to 2 as I can get without going over, that's impossible. Actually, this isn't too bad. The third root of y to the third, that one does divide evenly, so that's just y. And lastly, the third root of z to the 6. 6 divided by 3 is 2, so that one also works out nicely. So everything not inside of a radical is 5y z squared. Everything inside the radical is the third root of 6x squared. Don't forget that third root. I forget that a lot. How many questions over those? We're going to skip the you-do section. Since we don't have a lot of time, I really want to make sure we get to that other stuff. So, multiplying by binomials is more difficult, I think. However, I don't know if I have very many of these. I guess the best way is when I'm multiplying these, when I have these binomials, for the most part, they're going to be square roots, which is going to make it a little bit easier. But again, the biggest thing is make sure you know what you already know. Make sure you're multiplying whole numbers by radicals, and make sure you're reducing and simplifying. So, for instance, this first one, sorry, square root of 3 times 2 is just 2 root 3. You can't do anything with that. Square root of 5 is, multiply those together, square root of 15. Check to see if you any of those radicals. You can, so that's your answer. I should have picked one that you could reduce, but I guess I didn't. $18, same thing. We simplify or we distribute that. 2 times 4 is 8. 2 times 3 root 2. Again, that 2 does not affect the radical at all. We can only multiply whole numbers by whole numbers. 2 times 3 is 6. And we don't do anything with the root 2. Again, that's already simplified as I can get. And we have 221s. Okay. Now we're getting into the foiling problems or the double distribution. Or again, don't forget what we've learned before. It's just a normal foiling, first, outer, inner, last, or distribution. 2 times 3 is 6. 2 times square root of 3, we can't combine any of that. That just stays 2 root 3. Again, just like if that was an x, just be 2 times x. Then root 3 times 3, again, we can't do anything with that. So 3 times root 3. Then lastly, square root of 3 times square root of 3. Again, there's a little bit of a shortcut you could do, but if I were you, I would just go ahead and say the square root of 9. Deal with that later. We simplify the 3s, the square root of 3s, we can reduce. This is why we're bringing in the adding and subtracting part. We can add those together because they're both square root 3s. So that is 6 plus 5 square root of 3. Then the 9, we can reduce that down. The square root of 9 is just 3. So last but not least, the 6 and the 3 can combine to get 9. So that is 9 times the 5th root of 3. These will look like. I don't think I give you any that are too terrible. I've certainly done some of them that you end up with a lot of simplifying, and it's same thing. 4 times 5 is 20. 4 root 2 is 16 root 2. Times 5 is 10 root 2. 2 root 2 times 4 root 2 is 8 square root of 4. And 4, we can combine these two. That is 26 root 2. 20. And 8 root 4, be careful, because this is where a lot of people mess this up. A lot of people say it's 64 times 2 or something like that. No, they didn't do anything. So it's just 8 multiplied by it, and square root of 4 is 2. So really, that's 16. Maybe that's a better way to 8 times 2, and that's 16. Depends on how many times you want to rewrite this, so that might save us a little bit. Make sure you remember 1 times 16 is 36 plus 26 root 2. And the last one, again, when we FOIL this out, this is an interesting one, so pay attention to this one. And I assume we'll talk about this later, but 3 times 3 is 9. 3 negative 2 root 5 root 5. 5 times 3. Remember the root 5 multiply simplified by anything. There is no other radicals. Positive 2 root 5 times negative 2. Positive 2 times negative 2. Square root 25. 5 times 5 is 25. Again, people forget because they're used to adding and subtracting now, and so they accidentally say 2 times 2 is 4, and then they flip the square to 5. Multiplying those radicals still. Don't forget about that. So that one wasn't different than what we've been doing, but now it's a little bit different. Negative 6 root 5 plus 6 root 5 is 0. That's 0 root 5. If you want to put that down, you can. And then we have negative 4 times the square root of 25 is 5, so that is negative 20. So now when we combine, 9 minus 20 is negative 11. Root 5 is just 0. So the unique thing about this is that all the radicals cancel each other out. We did something similar. We talked about it with imaginary numbers to get those to cancel. We talked about conjugates. Same thing with this one. This one is not imaginary. It's a radical. It's called a complex conjugate. They're the exact same, but one's a plus and one's a minus. All your square roots to cancel. As of right now, you don't have to know that that's a conjugate. I don't know. I forget if we talked about dividing or not. We'll see. Any questions on those? Now, again, in my opinion, I'm not going to stand up here and say this is easy at all. I don't want anyone to think that, oh, man, I don't know how to do this. I'm done. That's not the case. I do think this is doable. I believe all of you guys are intelligent enough to do this. So really, in my opinion, the make or break all depends on if you're willing to do some of these worksheets. Make sure you use your exponent sheet. Make sure all that stuff is you're using to your advantage.